All right. Hello, everyone. I hope you're doing okay. We got a lot of upgrades here, but we're still not quite at the bingo research facility. So we have revealed antimatter condensers here in the upgrades that we can buy, or the buildings that we can buy. I mean, there's lots of stuff that's been going on in this game, but this bingo research facility is where the game starts to get like kind of weird, as if clicking cookies wasn't weird enough already. When you unlock the bingo research facility, you start to get into this state where the grandmas start to turn really evil and awful looking, and it's a little bit terrifying as you keep going. But I mean, a grandma in this case is a building that you're buying, so it seems sort of fair, I guess, that the grandmas would rebel and start to turn into something else. But we'll have to wait until we have a quadrillion cookies to be able to start doing this research facility stuff. So maybe by Tuesday next week, if I leave this running all weekend, we'll have a quadrillion cookies and we can upgrade to the bingo research facility here. All right, so what I want to talk about today is to keep thinking about this idea of MVC and thinking about our implementation of MVC. Last class, we took it was a pretty fast ride through implementing a basic MVC architecture. We accomplished the task that we set out to accomplish. I clicked the button and eventually stuff showed up on the page. The view started to get changed based on the model telling it that it had changed. The controller was responsible for accepting the button click. The controller asks the model to change. We've got this nice triangle shape of like things actually happening here. But we were moving fast. We built all this up. We were touching lots of different things, thinking about TypeScript, thinking about interfaces in TypeScript, building up domain model instances, starting to think about HTML, starting to think about how we're hooking together TypeScript and HTML, using this document object to be able to get access to elements that are on the page. And so today what I want to do is spend a little bit of time just stepping through this. So not writing any code anymore, but just like kind of following this flow of how we go from starting this page up all the way through to the button has been clicked and stuff is starting to show up on our actual page. If you want to follow along with what I'm working through today, I did push up the changes that we made to the code, to the repository that's linked under today's lecture section. So if you have that Git repository already, pull it. If you just want to follow along on GitLab as I'm stepping through stuff, that's also a good place to do it. The other thing that I want to do is introduce this idea of testing with frameworks today. We're not going to dwell too much on the idea of testing. That's something that we did in Comp 2450. I'll give you a quick review of the stuff that we did in Comp 2450, but the goal today is to focus on how do I use a framework to write the tests that I want to write for my code, as opposed to what testing is as a grand idea. So what I want you to be able to do by the end of today's lecture is continuing. So as of at the end of Tuesday's lecture, I want you to be able to implement this basic idea of this MVC architecture in code. And after today, I continue to expect you to be able to do that, but I'm also expecting you at this point to be able to like work your way through this code, like follow a path from the starting point of I'm loading main.ts all the way to the button has been clicked and this new entry is showing up in my list of Pokemon. The other thing that I want you to be able to do by the end of today's lecture is I want you to be able to use a testing framework to automate running test suites. So we will write a couple of tests to get the point across of how do we actually start interacting with this testing framework. But the goal here is really just let's get our project set up so that we can have tests in it and so that we can use this testing framework that we're going to be using. So let's take a look at our implementation of MVC. The first thing I want to do is spend some time just taking a look at the code. So I'm going to bring up my terminal and we'll take a look at our code together. And again, the goal here is go from part one all the way to this new list item is showing up on my page. How do we get from here to there? And the other thing that I want to do is I want to draw a sequence diagram. A sequence diagram is another way for me to kind of describe visually how these different things are interacting with each other, but summarized visually in a diagram, as opposed to me pointing and waving my hands at the screen about what line of code we're currently on. So first things first, I'm going to go over to my terminal here. I've got the 2452 Iman repository here. Again, if you want to follow along on your own screen, either pull this repository or go to the link that I provided to you on the course webpage. The very first thing that I want to look at here, and the first kind of point of stuff getting loaded, is this file that's called index.html. At the back, is this big enough for you to see okay? Yeah. Okay, awesome, thank you. This is the very first entry point to our application, this idea of index.html. This is a standard. I'm not sure if it's actually like a standard that's written down in terms of how HTTP and HTML work, but this is a standard in the form of index.html is the default page that gets loaded when you go to an address. Yeah?
As far as I'm aware, it's a real standard because you need to make subsequent pages in HTML with, in a folder with index.html. If you load that page in the website, it won't show the .html page.
That's true, but I don't know if that's just a functionality that web servers have in general, or if it's actually like a codified standard in terms of the IETF, the Internet Engineering Task Force, that sort of idea. So index.html, at least for us, for me, for now, it really doesn't matter whether it's a standard or not, is just this is the place commonly where things start happening here. On this page, the first thing that we added was this button. Eventually, I actually want to remove this from this page. This shouldn't really be the responsibility of index.html to have this button, but it was a way for us to start interacting with the page without having to do any of the coding stuff. We didn't have to necessarily have a controller yet. This was our entry point into having this controller set up. Eventually, what I want to do is take that button out and give that responsibility to a view. I want a view to have the responsibility of rendering that button and not this page itself. But for now, this is where we're starting. The actual code starts to execute here on the line that starts with script. So for this script tag, this is where we're beginning to have code executing in our web browser in terms of the code that we've written. Main.ts is going to be, for us, the name of the entry point. I'm going to tell you that I want you to use main.ts as a name for this. What you actually call this is irrelevant, but it's consistent with our other experience with programming languages like Java. Main is the place where we start running code, so let's just use this name main to describe this idea. So what we have set up here right now is we're going to load index.html. This is step one. We're opening that address in our web browser. Step two is we're going to start running code in main.ts. So this is load the page, and then two, start running code. The syntax that I've got here, this is a comment in HTML, open angle bracket here, exclamation point, dash, dash. This is a comment in HTML. You end your comment with dash, dash, angle bracket to describe a comment. So the page is loaded. That's the very first thing that happens in our web browser. And then we're starting to run code in main.ts here. Main.ts is over here in our source folder. So we're now starting to execute this code from the top. This is a script file that we're starting to run with. The first things that we're doing here in main.ts is we're starting to set up the controller. So our entry point here is going to have the responsibility of initializing the controller. So this is step 3 in the process that we're working on right now. Initialize the controller. then trainer controller here, in its constructor, is going to start creating instances of the state that it needs to maintain. And it's going to start creating instances of the views that correspond to those objects that it's creating. So main.ts is starting to initialize the state, initialize the controllers. The controller's responsibility, this is now step 4. Initialize internal state. And then part of this is initialize the view. So I want to initialize this object. My controllers have the responsibility of creating instances of domain model objects. And our controllers have the responsibility eventually of asking those things to change. But for now, in the constructor, the task that we have is I want to initialize that object. So I want to make a new instance of this trainer domain model object. And I want to make an instance of the view. So controller responsibility, make domain model instances, ask them to change eventually, but also figure out what view should be on the screen right now based on what's happening. When we're setting up index.html, the thing that we want to do is we want to have this trainer view that's going to represent the state of that trainer loaded onto the page. And so I'm going to pop over here now to trainer view. Whoops. In the constructor for trainer view, we're past this instance of trainer. And this is now step number 6. We're going to bind the view and the domain together. The view class is going to be attached typically to one thing. My trainer view is responsible for showing me what one trainer looks like on the screen right now. It might be responsible for showing like the entirety of that trainer and all of its sub-properties, so the team of Pokemon that it has. But it, for now, is responsible for showing one single trainer. The register listener method, and we're passing it this, is I'm trying to say that this view class, this instance of this view class, is interested in knowing about when that instance of the domain model object has changed itself. And so this is going to take me to one more place. I'm going to go over now to the trainer class itself in the model. The trainer has been initialized. I skipped over this part because it's really just creating instances of arrays. We're not really doing anything meaningful here. But now we're at the point of register listener. The view, as part of its own initialization, is saying, I'd like to be added to this list of listeners, please. When you make changes to yourself, instance of trainer, I'm somebody that wants to know about that. So when you make changes to yourself, please notify me that that's happening. But for now, I'm just saying I'm interested. I'm not really going to do anything with this right now. The trainer is not changing itself. I'm just interested in knowing about changes to that. Going back to the trainer view, after I register myself as somebody that's interested in having notifications of changes to the internal state of that domain model object, I'm going to continue. This is step 7 now. Set up the view for the object that I'm working with. Setting up the view here involves interacting with that document object. So document, remember, this is this kind of global scope variable in a web browser. When you're operating in a web browser environment, document represents the HTML document that you're seeing in your web browser, but it's an object that you can interact with. So document here effectively corresponds to, kind of mentally and abstractly, that entire HTML tag, starting with HTML ending with HTML. Everything that's in there is represented by objects that are referred to by this document object that we have in scope everywhere in a web browser. This is not something that you have in Node. There is no document in Node. There's no concept of that. But when you're in the web browser, we have this document object that we can start to work with. Document here, what I'm asking for is I'd like to get a reference to the object, the HTML object that has this ID of app. So $sign represents identifier. App here is going to be, this is the identifier that I want to find. I'm going to go back to index.html fairly quickly here. That's getting me an object reference to that div. And what I want to do with that is I want to put stuff inside of it. The stuff that I want to put inside of it, I am the view now here. The stuff that I want to put inside of it is, here are some HTML elements that I want to work with. So I am representing the trainer, so I'm going to add this div. A div is just this structural element that lets me put stuff inside of it. It doesn't show up on my page in any way. I want to represent a div that I can put stuff inside of, and it has an ID of trainer. And I want to put inside of that this unordered list. So UL unordered list, this is going to show up as bullet points when I start adding things to it. The very last thing I'm doing here, this is for convenience. I'm going to refer to this list so that I can add elements to it. So I'm just going to get a quick handle on this thing. I want to add stuff to this unordered list, so get a reference to it for convenience sake. Yes. This isn't necessary for me to do this as part of the view. I just don't want to write document.querySelector every time I want to do something with that element. I'm going to use this often, so I'll just keep a reference to it here. At this point, our document, when we look at it in our web browser, we'll have that div of ID app, and then inside of div ID app, there's going to be div ID trainer with UL empty. It doesn't have anything in it. Our trainer doesn't have any Pokemon yet. We haven't clicked that button. No other interactions have taken place here. So if we pop off of the stack of places that we're currently looking at here, we're going to go back to trainer controller. That's the end of our constructor here. And then we'll go back to main.ts. The very last thing that we're doing in main.ts, and if I'm counting correctly, this is step number 8. This is now register the controller method that we want to invoke with the button that's actually showing up on the page. This is a responsibility of the view, and it really doesn't belong in main.ts. This was just helping us get to this point. What I would want to do eventually is I want to move this into trainer view. Putting the button on the page and connecting the button to the controller, that should be the responsibility of the view itself and not main.ts. All I really ever want to do in main.ts here is initialize my controller. Yeah.
So how do we decide that this button goes to trainer view if we're kind of dealing with Pokemon or passing Pokemon here? So isn't it belonging to the Pokemon itself or to the thing that we change the state of?
So the question is, how do we decide whether this goes into, how do we decide whether this goes into a Pokemon view versus a trainer view? Actually, the granularity that you have here is kind of just depends on how granular you want to be. I could have a trainer add Pokemon view. that could be the view that I have for this thing. And the controller will have the responsibility of creating that instance. And then the view itself will decide, like, this is how I'm going to connect these things together. So I've got this button that I've just added, and I'm going to add this click action listener to it so that I can invoke this, this method on the controller.
So kind of the same domain model object can have different views for different responsibilities?
Yeah, the same domain model object can have different views for different responsibilities. And this is one of the powerful ideas of MVC as an architecture. I can have 4 or 5 different views that represent the same instance of the same domain model object. And if they're all registered as listeners, when that domain model object changes, they will all update themselves because they will all be notified by that domain model object.
Okay, and what about the controllers? Like at this point, we have a controller that is responsible for a single domain model object, the trainer, essentially because it is keeping as a private property, the trainer object. But can we have like controllers that are responsible for keeping multiple domain model objects?
We can and will have controllers that are responsible for multiple domain model objects. However, we're also going to start moving some of the state that we have in the controller right now into the domain model objects as we proceed with this. So while the controllers will have the responsibility of initializing those instances, the instances and the classes themselves will have the responsibility of kind of maintaining their own internal state. So our controller won't necessarily have a list of all trainers. The trainer class will have a list of all trainers. And the controller can refer to that list of all trainers if it needs to, but it's not something that we're gonna leave in the state that it's in right now in the long term.
So kind of like what we had in our first project where, for example, the list of all profiles were kept not in the domain model object, but in the logic layer.
Yes.
Here it is the domain model object that keeps the entire state.
Yes. So when in Comp 2450, when we were using that layered architecture or the N-tier architecture, ultimately the responsibility of keeping track of all things was the persistence layer's responsibility. Ultimately, that's where we got to. When we started, the logic layer definitely did have those object states. It kept track of all the things, but eventually we moved that into the persistence layer. And so this kind of comes back to that idea of the view has logic and persistence the model has view and persistence responsibility in this architecture. So the model itself will have the responsibility of maintaining that state in the long term. Yeah. Yeah.
You briefly mentioned, for example, the add Pokemon button, like it should not be in index or HTML. Do you instead like want to put it in trainer view or like any other like view file?
In some other kind of view file, yeah.
So in our projects, like if we have like multiple like elements that we can click on and interact with, we should not have like those elements in index. We can have them in like their own separate TypeScript files.
So if you want to, the question is about, I'm going to go back to here. The question is really about, I think, is it okay to have buttons here? Is it okay to have anything that's not this and this? I think that's ultimately what your question is. And yeah, it is okay to have those things. But the problem with having those things in index.html is that when you want to like change the structure of the view, I want to fully remove this view from the document. If parts of it are here and parts of it are in the view.ts file, it becomes difficult to manage removing everything that is part of this thing. If I have it fully contained in that TypeScript file, then it's going to be straightforward to go through, and I know that I'm responsible for these elements in this class, so I'm going to remove these elements in this class. Yeah.
By the way, are we going to have just a single page architecture, like a single page application, like just that indexation file?
Yeah, so the question is about single page architecture. This is a single page local first application. So everything is going to be rendered ultimately in index.html. Our index.html will be fairly bare bones as we continue because of what we're talking about here. I want to put all this responsibility into those view classes, so they'll have the responsibility of updating the display. We're also not going to be interacting with any external services. So we're not going to be issuing GET or POST requests to do anything. Everything is going to be hooking buttons up like this and connecting everything together that way. Yeah. Any other questions about where we are right now?
refer to any HTML code that we have? Or...
Document refers to the current page that's in the web browser. This again is, I don't really want to have multiple HTML documents and move around because I want us to have a mental model of this is document. More generally though, in a web browser, when I'm moving around, so right now, document here refers to what's in my slideshow here. So this is document in this tab. When I move to Learn here, now document is, in this context, this web page. If I move between web pages, document will change to reflect whatever the current document is that's showing up on the screen. For us, for this course, I really want to keep this as simple, or I want to keep this as this is document for us. This is the page that we're going to be working with. Yeah.
Would it go inside like this? Let's say, like, what if by all then it would just be re-rendering the button all the time? It would be more like a setup thing, like a setup method.
When I move this to the trainer view class, I would put this kind of like what this one is doing. I'm going to add that button to the page in the constructor once. I will also connect that button to the controller only once. This is something that would happen at setup. The other thing that I will need to change about the constructor here is I do want to continue accepting this instance of trainer, but I will also have to accept the instance of the controller that I want to interact with so that I can connect those things together. Okay, so we're back at main.ts here, and we're done. We have finished setting up this page. We've got a controller, we have a domain model instance, we have a view. All of these objects are kind of in memory right now, and they're just sitting there waiting for some interaction to happen. I click on the button. So let's put in our heads this mental image of the button that says add poke with E accent aigu Pokemon, add Pokemon. I've clicked on the button. Now, we're not going to do anything in this document. We're not doing anything in main.ts. We're immediately going to start executing code in the trainer controller instance. This setup that I've got here, when this click event happens, I want you to invoke this method. So I've got this anonymous function. I want you to invoke this method on trainer controller that's called add to team. And so I start running in add to team here. If I am counting correctly here, this is step number, this is step number 9. The button has been clicked. Whoops. We're starting to run code in this controller. I've clicked on that button. The action for responding to that click event is I want to start running code in this object. This object is going to create an instance of a Pokemon. I'm not going to go over to Pokemon here. Creating an instance of Pokemon, for now, all it does is initialize that initial HP to 10. That's the only thing that this does. It doesn't do anything else. Eventually, calling the constructor may actually fire events. Calling a constructor may fire the event of something has been created of this type, because there might be people or things or views that are interested in knowing has something actually been created here. But for now, nothing happens. There's no magic here. There's nothing beyond just initialize this object of type Pokemon and pass it this hard-coded value of 10. Then we ask the trainer instance that's attached to this controller to change itself. I would like you to take ownership of this object instance that I am passing to you. I want you to add this Pokemon to your team. And so that now takes us to the trainer instance itself. The trainer, when I add to team, will accept that Pokemon, and it will push it onto its team of Pokemon. But as a result of modifying itself, it's now going to say, I want to notify everybody that's listening for changes to me. Somebody, or nobody in some cases, has registered interest in knowing that changes have happened to my internal state, so I want to notify them. This takes us to this private notify all method or function that's attached to this object, and we've got this array of listeners. Right now, there's only one listener, but the power of MVC is that we could have many listeners for this. We could have many views that represent what a trainer is. For now, there's one, and there's only the trainer view instance that we created in the controller in the first place. So it was kind of bound together with this object. It registered itself as a listener, and now it's going to be notified that this has happened. This change has taken place. The notification that we're passing to this right now is primitive and very coarse-grained. Something has changed about me. All we're able to do right now, when I go to one of the notify method that's in the trainer view itself, so the .forEach here is we're going to iterate over every one of these things and call this notify method. Right now, this is a very coarse-grained, I am going to erase everything that I know about trainer right now and just rebuild the whole thing again. It's not very optimal. We're doing this every time that button is clicked. We could make this more optimal and have finer grained events that are added Pokemon events. I don't want to do that right now. I really just want this idea of notify. Something has changed about me, fully re-render this entire view. The trainer has had its internal state changed by itself, and now it's going to notify everyone that's listening here. If I'm counting correctly, this is now step number 10. We've received an event notification, so we want to re-render our view of the trainer. And so I'm going to just empty the whole thing. The thing that we're caring about here is that list of Pokemon. I want to erase this entire list of Pokemon. Team el.replaceChildren just replaces all of its children with nothing. This just removes all of those elements from the document. And then for each of the elements that are in this team, each of the Pokemon that are in this team, we're going to go through the process of creating an element. We're going to put something inside of that element here, and we're going to put that element onto this document. So I'm going to add it to this unordered list that I previously created. When this notification is done, I've been notified that this change has taken place. Now we pop back over to trainer. There are no other listeners here, so I don't really need to make any more notifications. I only have one right now, but I could, in theory, have more that I'm notifying. I'm going to go back now to the add to team method. We're done here. I'm going to return back to the controller. And what I've got in controller here are some console logs. I'll comment these out because they're really not meaningful here. And we're now finished add to team. We go back to the state of the browser is sitting around waiting for us to do something again. We're initializing our controller. The document's loaded, initializing controller. The controller is setting up some internal states and deciding what views to show on the page right now. The view is binding itself with the object that it's listening for and setting up the view that it represents for this thing. The button is clicked. We add to team. We ask this trainer instance to change itself. It notifies all of the listeners that something is happening. The listener is notified that something is happening. It changes its own representation of that object. And then we go back to that main page and we wait around for something to happen again. Are there any questions about this?
For example, like cookie clicker, right? There's a bunch of upgrades, with, like whatever like you can add on the like on the page, right? Are these all like listeners, like just like you said, like a fiction array, and we're like checking which event has happened, and then we're like doing notification.
So I can't buy upgrades here. I'm going to ask you to just use your mind's eye to imagine me clicking on this and pretend it's an upgrade. Functionally, the same thing is happening internally. I've got these buttons that I can click on this page. And to be very clear, I have no idea if Cookie Clicker actually uses an MVC architecture, but I'm going to describe it as though it is using an MVC architecture underneath. When I click on this button here, there is going to be a controller that's going to respond to this click. When I click on the button, the controller is going to ask for something else to change its state. I'm going to say that we have a game state object that represents what our game currently is right now. When I click on this button, the controller is going to say, this object has been purchased. Part of why I want to take this and move it into that view is that I can then change what is being passed to the controller method to represent something that is in the view that I want to have. A new instance of an object, a string that represents something so that the controller can make that instance of that object. I want to have that in that view so that I can do those things without having to have it dumped into this main.ts file. So when I click on this upgrade button here, the button is probably saying to the controller, I want to purchase this item. I want you to add this to the game state. The controller then is going to tell the game state to add that to itself. The view for the game state, which includes this and this cookies per second here, they are separately, assuming these are separate views, they are separately going to be notified that this change has taken place. Click on this button and 10 cursors are added, and you can see 10 cursors showing up on the circle that's around the cookie there. When I buy more grandmas, you can't see them anymore because they've gone off the side of the screen here, but there's more grandmas that would show up in this view. When I buy more farms show up, but it's gone off the side of the view. So for each of these buttons that I'm clicking, I'm asking something to handle the event, the controller. The controller is then going to change the state of the model object that represents the thing that we've got, and it's going to let the views know. The views are going to change their state on the page as a response to that. So it's the same kind of full circle path that we've just done with our own minimal example of this.
When you say like a single view, you can have a bunch of lists. That means like there can be a bunch of upgrades, like they all affect the cookie. So like the cookie knows like which upgrade has been played because it has like a list of all of those listeners. It can check.
The controller is going to respond to the button clicks itself. So the view, this view, I'm going to click this upgrade button, multiplies the gain from 1,000 fingers by 20. When I click on this, part of the view's responsibility then is this upgrade has been purchased. I should remove it from the display. I don't want that to show up anymore. That shouldn't be part of the things that are available to me anymore.
What parts of our architecture are ever going to implement this the listener interface? So right now it's the trainer view is implementing listener, but like trying to wrap my head around what other parts of our architecture might use the listener.
The main thing is going to be the view. The view is going to be the main thing that will implement the listener pattern. The controllers may implement this pattern, maybe, if there are complex interactions between different domain model instances. I'm going to say that that's unlikely to happen for this course, but it would be reasonable for you to want to do that. The other kinds of things that could, and I'm definitely not saying this is going to happen, but you could continue to use this listener pattern to do things like having a fully separate persistence thing that's just listening for changes to the domain model instances. When those changes are made, then you should invoke some kind of persistence code that's going to persist those changes to the state that we've got. Does that answer your question? Yeah, okay. And we could further have even interactions between domain model objects this way. We could have like one domain model instance having a listener on another domain model instance, and they notify each other that things have happened. That's also possible for us to do that. Yeah.
Right now, our button is in the index HTML file. But we'll have like a certain amount of things that are going to show up when you start the game. And is that just like each of what it belongs to? It goes in that view, and you do a query selector on like body, or does it have to be within a div? Like
I'm using the, so I think the question is about like, what about stuff that should always be on the page? And so there is some implication that this should always be on the page. That's fair to have things that are always on the page, but I would still put them in the corresponding view that represents what that idea is. And what I would do is I'm always going to add stuff to this div. I want to keep things fairly simple in terms of like interacting with HTML documents. You can have a lot of fun with HTML elements here if you want, in terms of all of the different elements that there are, and there are many, many different kinds of elements. But you could do things like, for example, instead of using divs, you could use sections to represent the different parts of the page that you have on the screen. You can have things like, you can't use marquee anymore. I'm trying to remember what it is, dialogue. You can have things like dialogue here. This is something that's meant to represent like a pop-up of something. I don't really care if you want to use these or not. This is not something I'm strictly requiring. It's available to you if you want to use it. To your question of stuff that shows up permanently on the page and stays there, a view can add things to the page that will just always be there. If this view is always around, then that thing will always stay there. If the view is removed and you want it to be removed from the page, you don't want that button to be there anymore after this event has taken place, after this controller has finished responding to it, then the controller can have the responsibility of asking the view to tear itself down. So remove yourself from the page. Do document.querySelector here, and then replace children with empty. Remove myself from the page. I don't want to show up anymore. Yeah.
So like for each distinct interaction, we have a separate controller responsible for that.
For each distinct operation, it would be reasonable to have multiple methods within a single controller as long as they are operating on the same kind of object. You could have different controllers for different domain model objects. That's a pattern that I'm going to stick with. If when I want to make changes to a specific thing of a specific type, I will use one controller to do that. So to build on this even further, I would also have a Pokemon controller that would respond to things like, I want to change the nickname of this a Pokemon, or I want to respond to the attack button being clicked, or something like that.
Like for the trainer, we have a trainer controller, and within that, at this point, we have just a single trainer view.
Yes.
It is possible to have, like, let's say, trainer stats view and trainer team view.
Yes.
And those two will be within the trainer controller's responsibility to create them and like order them to display themselves.
Yes. So if we have two different views for a trainer, right now we've got this one, the trainer team view. That would be a much better name for this. Thank you for that. And then if we separately had a trainer stats view that described things like this person has this much money, this is their name, that sort of idea, it would be this class's responsibility to initialize both of those different views. They would both add themselves to the display in whatever place they wanted to add themselves, but it would be the controller's responsibility to set those things up.
And what about like if we want either one of them to be displayed? Do we create both and then just order them to erase themselves, but the object still exists? destroy the object itself.
If we want to just display one or the other, we would have a conditional statement in this code that's going to make that decision. Yeah. So the controller will have the responsibility of, like, it can make decisions. It doesn't just have to blindly add everything and then selectively remove stuff. It can just choose not to add that view until something has happened. There may be a button in here that is view trainer details, and then clicking on that button will cause a method to invoke here that will make a new instance of a new kind of view, and it will register itself to the page like that.
For the previous one that we already had before that, and we don't want that to be displayed anymore, like, do we destroy the object itself, or we just say, like, set the HTML that you were responsible for, the view, the first view that we have?
I would ask the view itself to remove itself.
So the object continues to, it just erases the HTML.
In the context of having this here, yeah, sure. But if you also wanted to further fully remove it from the page, you could set it to undef or null, provided you set that when you declare this variable. Yeah. Yeah. Yeah.
So like when we have multiple objects of the same class, we should add them all to the same controller.
If you have multiple views for the same class, I would be coordinating them within this same controller, yes. If you have multiple instances of a trainer,
Yeah.
at least for now, I'm going to say, yeah, you should put them here based on the architecture as we've described it in class. As you proceed, the model should take ownership of keeping track of all of the trainers in existence, because the model will become responsible for doing persistence. That's where we're going to start going after this week. Yeah. Okay. Yeah. Well, at this point, you were able to start doing your implementation for this. So you should have an idea of how to implement your domain model objects as TypeScript classes. You don't even necessarily have to set up the listener stuff for now, but you should eventually pretty quickly add the listener stuff to it. And then you should be able to start setting up views to represent these ideas. I wouldn't focus on things like style. This is going to look like hot garbage, and that's totally okay as long as we can interact with your app to accomplish the tasks that we want to do. I want to be able to click on a thing and see a number go up. I want to be able to click on a product and see it show up in a cart somewhere. I want to be able to click checkout and see a receipt. Yeah. Yeah. Okay. All right. There's a lot of tired, defeated looks out there. I'm hoping that this has given you a clearer view of kind of the flow of what's happening, as opposed to me rapidly typing and switching between files and adding new files and kind of making lots of changes in lots of different places. I will push up this commented code to the repository after class today so that you have the comments and you can kind of follow the flow of what we're doing. But I do want to add for you one additional visual representation of these this kind of flow. We've got comments here, 1 to 10 here, describing the different ideas, but I also want to have some sequence diagram that describes these flows. So very, very quickly, I'm not going to dwell for too long on this. I just want to have another idea of what the structure of this looks like. Sequence diagrams are a common way to describe the interactions and complex interactions between different classes. They typically look like rectangles at the top. These are going to be the major concepts that I have in this system. And I'm going to add 4 of these rectangles at the top of my page here. I'm not purposely avoiding the lines, but gosh, I am not an artist. So you'll just have to accept that that's where I'm at in my life. I'm never going to get any better at this. The interactions that we've got for our system right now consist of, I'm going to call this main. Main here is really going to represent the idea of the page is loaded by the person that's sitting in front of the computer. Index.html is brought up in their web browser. We've got this idea of a controller. The controller for us is that trainer controller. That's the only kind of controller that we have right now. We've got the model. We've got two different domain model objects and two different kinds of instances that we can have. We have trainers and we have Pokemon, but the only thing that's really interacting with other things at this point is the trainer as a domain model object. And then we've got this idea of the view itself. Beneath these, I'm going to draw some lines. And when we're reading sequence diagrams, we're typically reading them from top to bottom. So the top thing that we're drawing on this represents the first thing that's happening. The very bottom thing on the diagram that we're drawing represents the last things in terms of a timeline that's happening as a sequence of events that are happening. So when we first load this page from main.ts, the responsibility of our main is to initialize the controller. We call the constructor on the controller that we want to create. After I've called that constructor, or while I'm calling that constructor, the controller's job then is going to be, in some cases, to call constructors of our model. And it's also going to have the responsibility of calling the constructors on views. The way that we set it up, the view has the responsibility of binding itself with the domain model object or the domain model instance that's been passed to it. And so I'm going to draw that arrow this way. Bind itself, and I'm going to say listen. This is going to say I want to be notified of things that are happening. After that has all been set up, the page is visible. There are things that we can see on the page that we can interact with. Then I'm going to click on buttons. And I'm going to say that this is the view now talking directly to the controller.
We'll send the request to the controller, but then we don't have a reference for the controller in our view code. So
the goal that we've got is to take this and put it into the view. And part of putting this into the view is going to be that we need to change the constructor here to accept an instance of the controller. Yeah. So it will know about it. For now, as it's set up, it kind of knows about it in that main has created it and it has that reference. But ultimately, to tie them all tightly together, I'm going to make that change to this. So in the long run, we're going to have that reference to the controller in the view itself. I'm going to click on this button. And the controller's job then is going to be to interact with domain model instances, call more constructors, as necessary to respond to the button that's been clicked, or call mutators, call set methods, call methods that change the internal state of this object, ask that object to make changes to itself. The model then will make those changes to itself, and it will finally notify the view. It's going to notify anybody that's listening right now, hey, I've updated myself. You should update whatever you're showing because I've updated myself. time is going down here. We start at the top and we're working our way down to the bottom in terms of the sequences of events that are happening. This is a very abstract representation of that model that we've got. It's not me stepping through code, but this is another way to think about the kinds of interactions that are happening between these different things in our system. All right. I will share this diagram with you after class, so if you weren't able to copy it all down, it will be up on the course webpage under today's lecture notes. What I would like to do now is to switch topics and take a look at the phase 1 implementation rubrics. I posted this up on the course webpage yesterday, and I wanted to let you know about it today. I'm not going to dwell too much on this. The main thing that I want to take a look at here is how you will be assessed on this. What I want you to submit when you're submitting this is really the entire project structure that you've got. So if you were just submitting the domain and flows markdown file for the first part of the design, I'm looking for you to submit the entire project folder this time. I do want you to include your domain and flows markdown file in that project folder. You can put them at the root of the folder. So not inside of source, but in the directory that contains source. So the one that is named as your project. If you haven't made any changes to the domain and flows as part of your implementation, you can leave them the same. They don't need to change when you're submitting them again. If you did make changes to them, you started working on your implementation, realized I should probably have this property or I should have this class, change it and document it. Describe the change that you've made so that the person reviewing what you've submitted has an idea of how you've made changes to the flow or the domain model that you've got. The README, you can blindly copy mine, just replacing your own stuff in here. When this is being submitted, what I really want to be able to see is how do we run your code? And the way that we run your code really ought to be this. I run npx vite in your directory and it starts. That's the only thing I really want to have to do to start your code up. The npm install step here is if you don't have node modules, and this might be part of that archive, if you are using Git and version control, it will not include ignored directories. If you don't have it, the npm install installs everything that's necessary as prerequisites to get started. But ideally, this is all I want to be able to run is just npx vite in your directory to start your stuff. This is what I'm looking for you to submit in terms of an example of the structure of the package that we want to see within the zip file that you're submitting. And the way that we're doing assessment here is on some learning outcomes that are from Comp 2450. So we're reassessing you on this, but there's also new stuff from Comp 2452. So using a build and dependency management tool, I want to be able to run npx vite. If we can't run npx vite, the grading staff are just going to stop here. They're not going to keep going if they can't. It should work. It should work on different systems, but if they can't proceed, then they're going to stop at this point. The way that we're looking at your architecture stuff is we're going to visually inspect your code, and we're going to start to look and make sure that you've done things like you don't have view responsibility in your controller. The controller is only responsible for making the views, and the views do everything themselves. The view code doesn't really have any logic. It's not changing properties directly of objects. It's asking the controller to do that. That's the sort of thing that we're looking for with this. The functionality that we're looking for here is I want to be able to do all the tasks that I've asked you to do for each of these different project ideas. So I want you to have all the tasks implemented that you've got. And what we're going to start taking a look at immediately after this is I want to be able to run a test suite on the code that you've got. We want to be able to run a test suite on the code that you've got using a testing framework. The testing framework is called vtest, and we'll talk about that almost immediately after finishing this. And that's it. We want to be able to run tests on your code. The tests are limited to testing the domain model. We're not really too interested in testing your controllers right now. We're not doing UI tests. You don't have to test to see whether things show up on a page or not. That is not what we're interested in knowing about. The things that we're interested in knowing about is Does your domain model update itself correctly? And does it notify things that are interested in listening? But that doesn't have anything to do with the view itself. So I don't want you to do any kind of view testing here. That's not something that we're interested in for this course. I'm going to leave it at this for now. I will have some time scheduled on Tuesday's class next week for questions about the implementation, because I've just thrown a bunch of information at you related to this. And what we'll do right now is we'll start to take a look at some testing stuff. Okay, so a really quick reminder here. The idea that we're doing with testing is we're really trying to verify that our software does what it says it's supposed to do. That is the primary goal of testing. I'm trying to implement this feature or this functionality. I want to make sure that I've actually implemented that functionality. I want to try running that, and I want to verify that the output is what it is going to be. Part of the goal is I also want to verify that it works right now, but as I continue to make changes to my system, I want to make sure the code that worked still works after those changes have been made, especially as other parts of my system start to touch other parts of my system. For us, for testing, we had a few different ideas and parts. We had this idea of test data. So what are the inputs that we're providing to these tests? And what are the expected outputs? And we were thinking about different ideas like general cases and edge cases to represent those different kinds of test data. We have test methods. These are the things that are actually going to run the code. They're going to have the responsibility of hard coding this test data and then verifying that the output is what was expected. Did this exception get thrown? Are the side effects actually applied to the thing that I've got? Can I build this object the way that I want to be able to build it? In Comp 2450, we also wrote this test harness, or I wrote a test harness and I said, you can all just use my test harness, but we stepped through this idea of what a test harness is. And stepping through this idea of a test harness is, it's responsible for running all the tests. You have to call all of the test methods that you have written so that they actually get run by something. And it has the responsibility of collecting the results. How many tests passed, how many tests were there, and how many tests failed. I want to see what those outputs are. I want to see why they failed, that sort of idea. Finally, we had this idea of measuring tests. And when we had our guest lecture, at least in my section, we had Dr. Shaiful Chowdhury, and I asked him a very pointed question about this. Is code coverage a good way to measure the quality of tests? And if I recall correctly, he laughed, which I think is a good thing to do to that question, but it's a way to measure the effectiveness of tests. It's a way to measure them. It's not the best way to measure them, but it's a way to measure them. And for us, it's good enough for a class. So measuring tests is measuring the successes and failures and the coverage of those tests. Test frameworks are really about taking code that somebody else has written and then writing code for us that matches what that code is expecting. I want to distinguish two ideas here. We have this idea of a software library, and we have this idea of a software framework. A software library is typically code that I call. I am able to integrate this code and functionality into the code that I've written by calling methods. When we have Guava, Google Guava, it has preconditions as a class, and I can call methods on preconditions. I don't have to change the way I write anything. I just call those methods and it provides some functionality to me. This is tightly coupling. This is an example of tight coupling. I'm tightly coupled with the library that I'm interacting with. That's okay. That's typically fine. If it's a problem, I can address that with adapters. If I don't want to have to worry about calling the preconditions Google Guava library, I can add an interface here, and I can provide different implementations for that thing. In this case, tight coupling is often okay. Software frameworks now, this is code that's been written, but it's usually implementations of infrastructure, main methods, setting stuff up like dependencies between things, common patterns, like a dependency injection. Frameworks are code where we will write our own code, but it's more going to be from the perspective of the framework is calling the code that we've written. I'm not asking this library to do something. I'm writing my own little bit of functionality, and I'm expecting this framework to then call the functionality that I have written myself. This is tight coupling. There's no getting around this. You pick a framework, and you are now bundled with that framework. That's fine. That's a major change that you'd want to make if you wanted to switch frameworks. If you wanted to switch from, gosh, I don't know, Rails to Sinatra, if you're thinking of Ruby stuff, that would be a massive change to your application. This tight coupling is okay. It is fine. We don't want to try to avoid it. It's kind of on purpose. We are tightly coupling ourselves with this framework so that we don't have to do things like figure out how dependency injection works between dependencies. And I don't have to figure out how to bring up a web server. It doesn't matter to me. I'm letting this other code do all that stuff for me. The place that we're going to use a framework in this course is as a testing framework. And we're going to be using this framework that's called vtest. Vtest is nice because it integrates really nicely with Vite as a software project. It also provides a test harness for us. And the goal for this is that we can focus on writing tests. We have to write our tests in a certain way so that the framework is aware of them, but I don't have to write the test harness. I don't have to tell it how to find my methods that are my tests. I just have to write the tests themselves, and it will figure out where they are and how to run them. This is something that can also be configured to include test coverage. And so I want to quickly set up this project that we've got so that we have vtest as a dependency and so that we can actually start to write some tests here. So I'm going to head over to my terminal. And what I'm actually going to do to begin with is I'm going to quit Vim here. I'm going to save changes to that, and I'm going to save changes to this, and I'm going to save changes to that. The first thing I need to do to get vtest in my package is I have to install it as a dependency. With Maven, we opened up pom.xml, and we added some XML to this to say this is the dependency of my project. With Node, we are going to use npm to do that for us. There is a file that's kind of like what pom.xml was, and that's this package.json. They are functionally similar to each other, but gosh, I don't want to write JSON, and I don't have to write JSON, so I'm going to let npm do that for me. So I'm going to add vtest as a dependency, and I'm going to say npm install. I'm going to say -D here. This is for development purposes. I don't need this when I'm deploying this or when I'm giving it to my parents. I just need it for when I'm running stuff and building stuff in the back end. And I want to install vtest. It's added that package. And so quickly, if I take a look at package.json, I can see here that I've got vtest added as a dependency to my project right now. Running vtest is actually straightforward. I can say npx, and just like I could say vt here, I can say vtest. When I run this, can't find any tests because we haven't actually written any tests yet. And so that's step 2, is to start writing tests. The important part, though, is that it tried to find tests. I didn't have to write main. I don't have to call these methods or functions. vtest is going to find those things for me. I'm going to hit Control-C here to stop this. I'm going to open up nvim one more time. And what I want to do is I'm going to add a new folder for tests. It's going to be beneath 2452 Iman. I'm going to call this tests. So we've got public, source, and tests here. And what I'm going to put inside of this is I'm just going to start dropping tests directly in here. You can structure this differently if you want to. You can have subfolders if you want to. I'm just going to put all tests in the same folder for now. I'm going to make a test that's called trainer.test.ts. The framework is looking for files that have .test. In it. The names of the files are important here. This is code that's calling our code, and so we have to follow what it wants to be able to find. So I have to name it .test.ts. And I'm going to open up this file, and I'm going to start I'm going to have to start including some stuff in this. I'm actually going to go back to my web browser for a second, and I want to open up the vtest web page. And I'm going to go to guides here at the top. And the getting started guide here describes what we've just done, installing this as a dependency. But it also tells me about what I need to be able to bring in from vtest itself so that I can have some functionality for my test that I'm writing. So I'm going to have expect and test. I'm going to import those from vtest. So I'm going to pop back to my terminal now. Notice now that this is not vtest.ts. This is some external dependency that we're interacting with. This is not something that's in our current folder. We didn't write this. This is just library code that we're getting from somewhere else. To write a test, the way that we write tests is we don't actually write functions here. We're going to call this test function. The first argument that we pass to the test function is going to be a description of the test as a string. This is a hard-coded English language description of what this thing is testing. So the first test that I'm going to write here is going to be can add Pokemon to team. The second thing that we pass to this is the function that we want to be invoked to do the test that we're trying to do. I'm going to say that this takes no arguments, and it's going to have the functionality of, I'm going to make a new Pokemon. It has an initial HP of 10. I'm going to say let t equal new trainer. And I'm going to say t.add to team p. What I want to have at the end here is I want to have a test to find out, did the output actually happen the way that I expected it to? Do I have a positive outcome here? The positive outcome here that I have is I want to be able to inspect the state of this trainer instance, and I want to ask if its team contains the Pokemon. I'm going to have to add imports for trainer and Pokemon and stuff after this. I just want to get through the test itself first. I will update this on the repository after class to be functional before I publish it for you. So keep your eyes open for that. The way that I'm going to evaluate the outcome for this is I'm going to call this expect function. So expect is something that I've been given by vtest itself. And the way that we're doing these expects is kind of like natural language describing what it is that we're looking for. So what I want to be able to say here is I want to be able to say that I want to expect that t.team, that's the attribute, the array of Pokemon that this trainer instance has, and I want to say .contains p. I want to know, has this Pokemon actually been added to the team after calling this add to team function? I'm going to save this. Can't find name Pokemon, can't find name trainer. We do need to import these. It is 11:14:36. I'm going to do one last little test. And again, I'm going to update this to compile so that you can run it on your own. The other test that I want to do here, as I said, is I want to be able to test that my domain model instances notify listeners that something has happened. I don't want to test the view. I want to know that the notification thing is actually happening. So I'm going to write one more test here. The test is going to be trainers notify listeners. And the function that I want to run as part of this test is very similar to what we had. So let P equal new Pokemon. Let T equal new trainer. I'm also going to say let notified equals false. So I want to keep some state in my test to determine whether or not I was actually notified as a result of something. Then I want to say T dot register listener. I don't have a this to pass here, but I can give it something that satisfies the listener interface. The thing that I'm going to pass that satisfies the listener interface is this bare object that has a function or a property that's called notify. It is a function, and what this function is going to do is set notified to true. That is a listener. It satisfies the interface that we specified for what listeners are. Great. I can call this function. This function will be invoked if this is set up the way that I want it to be set up. Once I've got that setup done, I can say T dot add to team P. This should cause that listening thing to actually happen. And now what I want to say is I want to expect that notified dot equals true. For my test to be successful, this function must have been called as part of the notification process. I'm going to save this. I will update this to actually work correctly, but our next step here is to quit out of this. And when we run vtest here, this will fail because we don't have those imports right now. But when we run npx vtest, you can notice that it's actually calling these functions. It's beginning to call these functions to run the tests that we've got. And it's nice and shiny. It's not just tests succeeded, tests failed, and then us hacking in red and green text to represent passes and failures. So at this point, you should be able to build up and have this conceptual model of what our MVC architecture looks like. You should be able to begin implementing this for your own projects. And you should be able to use a testing framework minimally to automate running test suites. I will push up the working version of this later today so you have access to it. Otherwise, that's it. Thank you all for coming out on this very cold day, and I will see you all next week. Have a great weekend.